Hello, summer teacher. Now I want to explain first exercise, the 44th. Yes, I think you know the what's done. So I will explain how to find the distance from the end of the rope to the touchdown point. Firstly, the first question is at what angle it is goes from the end of the ramp. There is a x. We don't know what's the angle. So by the geometry, we can find this angle. So in exercise down that there is arc and 90 degree. So if we continue these lines, which is perpendicular to this this radius vector, and we can find that the 60 is done, and the risk must equal to 90 also. And by this equation, we find that x equals to 30 degree. Yes. So we know the this angle. So let's find the initial velocity when it will go from the end of the ramp. We will find it by by formula energy. Initial energy equals to final energy. First of all, this person has a potential energy mgh1, and zero, and don't have kinetic energy because it becomes starts from the rest. Yes, mgh1 initial energy equals to mv square over 2 plus mgh2, because this is a final energy. In this point, it will have h2 3 meters height. It will be at this height, and we'll have this velocity, which we must find. So by mass, we found that it equals to 21 meter per second. Then by two-dimension formulas, we using these two formulas, L equals to L. It's this distance. L equals to V cosine 30 multiplied by T, and second equation, H2 equals to V sine 30 multiplied by T minus GT squared over 2. This is simple two equations, and by using these two equations, we take this T and put here to the second equation, and we get this. So we have only one unknown, L, so we can find the length and distance. So by the math, we found that it is a quadratic equation. So quadratic equation will be solved by discriminant, and by discriminant we find that L equals to 36.7 meters. That's all.